This is the second lecture on exercise and the immune system. We'll be addressing exercise and the immune system, exercising in environmental extremes such as high temperature, low temperature, high altitude. We'll also look at whether or not you should exercise when you have a cold. So one bit of terminology that we should square away is upper versus lower respiratory tract. There's often a little bit of confusion about that. So the upper airway or upper respiratory tract includes the nose, nasal passages, the paranasal sinuses, the pharynx. So the pharynx is essentially the common tube that leads to both the esophagus and the trachea. And then the portion of the larynx, which is the voice box, above the vocal folds, which is where the vocal cords are. The lower airway or lower respiratory tract includes the portion of the larynx below the vocal folds, the trachea, bronchi, and bronchioles. Bronchi and bronchioles are tubes within the lungs. So there's quite a bit of evidence that the risk for infection, and we're talking specifically about the upper respiratory tract infection, or URTI, is impacted by the level of exercise. And so this is often described as a J-shaped curve. So people who engage in moderate, regular moderate exercise, say exercising every day for 20 to 40 minutes at a reasonable VO2 max, like 50%, 60%, they actually have a lower risk of upper respiratory tract infection. Now, compared to sedentary people. Now, the risk is actually higher in people engaged in really intense and or long duration exercises. So people that are really pushing to a higher level of intensity, such as 80, 90% VO2 max for a longer duration, they actually will have a higher risk of infection than sedentary people. So the basic finding is that moderate aerobic exercise protects against upper respiratory tract infection. So regular exercise reduces the risk of URTIs by 18 to 67%, which is pretty significant. And the type of exercise we're talking about is 20 to 40 minutes of exercise at 40 to 60% of VO2 max. That's sufficient. And there's also some evidence that resistance exercise may be beneficial. In other words, weightlifting or weight training. It's not as clear. There's fewer studies on weightlifting, but there are some evidence that it may in fact be useful in terms of boosting immune cells and things like that. So what are the mechanisms for these exercise-induced protection, essentially? Well, exercise causes boosts in the innate immune system. So part of the innate immune system were natural killer cells. Recall what these are. These are cells that circulate through the body and attack cells with abnormal surface proteins. So that would include virus-infected cells and cancer cells. And recall also that natural killer cells are not phagocytotic. They do not engulf cells. Instead, they release chemicals that lead to the death of these essentially damaged cells. And there's also a boost in neutrophils. Neutrophils are cells that engulf or phagocytize bacterial cells or foreign cells. Now, after a bout of exercise, the levels of these natural killer cells and neutrophils actually returns to normal within about 3 hours. And it's not entirely clear what's going on there. It may be that this boost in the innate immune system is simply very short. It's also possible we don't actually know exactly where those cells are going. Perhaps they're actually entering into tissues and doing work within tissue, something like that. Typically, what they do is they measure the blood levels of these various leukocytes. Let me see what else. So, in addition to this immune boost that occurs every time you exercise, there are other factors that are associated with exercise that are extremely helpful. Exercise has been shown to be extremely helpful for emotional stress. So they've actually shown that, with people that are going to therapy for depression, well, it turns out that exercising is actually equally good in some cases. It's equal to therapy. Better nutrition. Of course, if you're exercising, you should eat well, and that those things often go together. People that are exercising also think about nutrition more, and hopefully they're also thinking about getting adequate sleep. So when you combine all these things with exercise, then you get a natural boost to the immune system, which is extremely helpful. So unfortunately, as people get older, the immune system ages, and with people, particularly over about the age of 70, they may see a decline in their immune system ability to fight off disease. And this is termed immunosenescence. But it's been shown on a positive note that regular moderate exercise can improve immune function. And it does this in various ways. First of all, with immunosenescence, there is essentially an impaired response to vaccination. So when you give a vaccination, you're giving antigens, and the body should respond to that in an appropriate manner, such that when you actually are exposed to the virus later on, you're able to fight the virus off. But unfortunately, as people get older, due to this immunosenescence, they may not show a stronger response to vaccination. And then when they are attacked by the actual virus, they may suffer more. But regular moderate exercise actually seems to improve the vaccination response. In other words, when you get the vaccination, you should feel a little bit sick, right? You'll feel soreness in the arm and maybe sick for, at least one night, sometimes 2 days or so forth. And that's actually a good sign. It means that you're having a large immune response to the vaccination. And so older people will see an improvement with that, with regular exercise. They'll see increased levels of T cells in their blood. You'll also see lower levels of inflammatory cytokines in the blood and increased neutrophil phagocytic activity. So those are all very positive effects of exercise. And I put this picture in just to remind us that most of the studies have really looked at aerobic exercise. And so the main benefits appear to be through aerobic exercise, but we shouldn't neglect weightlifting. Any kind of resistance exercise is probably also quite helpful. And of course, resistance exercise does a lot of things that aerobic exercise doesn't, such as increasing bone density and strength. And another thing your book doesn't really talk about, but it's extremely important also, is diet. So for example, I have a picture here of a traditional dish from Okinawa. Okinawa is a prefecture of Japan. It consists of a series of islands south of the main island of Japan. And they include a lot of carbohydrates in the form of things like melon, sweet potato, and then they have protein in the form of seafood and eggs and tofu and so forth. And so they have a very healthy diet. Also, they have a really good, strong culture in which old people are encouraged to gather socially, and they're very socially active. So there's a tremendous number of people in Okinawa that are above 100 years of age and are actually quite healthy. Okay, so we understand that and it makes sense that there are good benefits of moderate daily exercise. So it's a little bit interesting that high intensity and long duration aerobic exercise actually leads to an increase in infection, but this has been fairly well documented. There was a lot of anecdotal evidence from marathon runners. When they'd go and run their event afterwards, they'd often fall sick. And often they would actually fall sick even during training if they were doing very intensive, say, world-class level training. So when we talk about prolonged exercise, we're talking about exercise that's at least 90 minutes. And if it's intense enough, this is going to have a temporary depressive effect on the immune system. They'll have a decreased level of B cells, T cells, and natural killer cells, decreased natural killer cell activity, T cell function, decreased nasal neutrophil phagocytosis, decreased nasal and salivary IgA. Immunoglobulins are another term for antibodies. So this is a specific class of antibodies. You'll also see increased pro as well as anti-inflammatory cytokines in response to prolonged intense exercise. And so it's been hypothesized that this essentially suppression of the immune system leads to what's called an open window, which increases the risk of infection. And why is this? Well, what causes this open window? Well, it may be caused by high levels of cortisol. So it's been shown that prolonged intense exercise can lead to high levels release of the stress hormone cortisol. And cortisol has a suppressive effect on inflammation as well as the immune system. There may be also other factors that lead to this open window. So naturally, when athletes go, travel to an event, they may lack sleep, or their sleep cycle may be disrupted. If there's a change in, say, their circadian rhythm may change due to the fact that you're moved to a new time zone. There may be mental stress. There's anticipation of the event and so forth, and maybe, stress that just goes along with any kind of performance like a marathon. And of course, this is probably one of the biggest factors is if you're traveling by air and then bus and so forth, and then you're meeting people in crowds and so forth, you simply have increased exposure to pathogens. And so that may be another route that leads to this J-shaped curve in which people that are doing these marathons and so forth end up getting quite sick afterwards. This figure is an illustration of what we've been talking about. So initially during exercise is often a little bit of a boost to the immune system. But afterwards, so this would be considered fairly prolonged exercises, 2 hours. And if we imagine it's fairly intense exercise, like running or something like that, then immediately after the exercise, there's actually a little bit of a suppression of the immune system. And so this leads to this idea of an open window. Okay, I already mentioned this, but let's just try and really understand this a little bit better. Why does prolonged intense exercise suppress the immune system? Well, as I mentioned earlier, prolonged strenuous exercise results in an increase in blood plasma cortisol levels. That's the stress hormone. So cortisol is well known to have an anti-inflammatory effect. It also inhibits the action of specific cytokines. So remember, cytokines are signaling messages that are released by cells such as neutrophils. It suppresses natural killer cells, and it also depresses T cells production and function. So it just has we don't have to focus too much on these individual changes, but you can see it has a general sort of suppressive effect on the immune system. And again, this may occur in conjunction with things like exposure to crowds, air travel, and stress. This is a picture from your book, just putting all the things we've talked about together. So these are factors affecting susceptibility of infection in athletes. So you can have increased exposure to pathogens with travel, exercise-induced immune suppression, primarily due to stress hormones such as cortisol. Perhaps when they're traveling, they have inadequate diet, or they may, in fact, be starving themselves a little bit in terms of trying to have a light weight and so forth for something like a marathon. There may be some elements of mental stress involved with taking part in an event. Lack of sleep is another issue. So all of these things together lead to increased susceptibility to infection for an elite athlete. So here are some take-home messages of what we've been talking about. Exercise can have both a positive and negative effect on the risk of infection. There's a relationship between the intensity and amount of exercise and the risk of developing an upper respiratory tract infection. And this leads to what's called the J-shaped curve. This J-shaped curve illustrates that moderate intensity aerobic exercise decreases the risk of infection, whereas high intensity and prolonged exercises increase the risk of infection. An acute bout of moderate exercise increases blood levels of antibodies, natural killer cells, neutrophils, and provides a positive boost to the immune system. So this comes back a little bit to the idea of homeostasis. The fact that when you have moderate aerobic exercise, this provides a transient boost to the immune system. This could be thought of as another example how exercise can enhance the control systems of the body that help to preserve homeostasis. An example I think I might have mentioned earlier would be things like with exercise, you increase muscle mass, and muscle mass, skeletal muscle is very good in terms of acting as a reservoir, someplace for glucose to be transported into after a meal. So it actually helps you control your glucose levels. So that would be an example in which exercise is very good for glucose homeostasis. And here we're talking about moderate exercise and how it helps protect the body essentially by boosting the immune system. We've also just talked about how high intensity, long duration exercises can have a temporary depressive effect on the immune system. This acute immune suppression following an intense exercise session provides an open window during which viruses and bacteria can grow, resulting in infection. So again, this goes back to, and there's quite a bit of evidence. And anecdotally, people first found that it was marathon runners would often get sick after an event. And then they did do quite a few studies to show that there was a suppressive effect on the immune system due to high intensity, long duration exercise. Within exercise physiology, there's been a lot of interest in extreme environments. People have gone to the tops of mountaintops, trained in deserts, that sort of thing. So one reasonable question is, does exercise in a hot environment compromise the immune system? We did discuss this a little bit before when, like, if you have an athlete who's exercising at a high percentage of VO2 max for a certain duration, you might recall that instead of stabilizing a certain plateau level of, say, energy use, it may actually continue to go up and up over time until the person stops. And part of that's because there can be a buildup. As the person is exercising in a hot environment, they may have a really hard time offloading all the heat that's being generated by their skeletal muscles, as well as their internal heat from internal organs. And so their skin will become flushed, they'll be sweating and so forth. But if they can't keep up with the heat production, the body temperature may increase. So this is extremely stressful. So hot environments are very stressful, particularly when you're exercising. And so it's not surprising you may have elevated levels of cortisol compared to a nice, cool environment. And I think most of us would prefer to say go running when it's cool rather than when it's hot. It can be really pretty awful if it's hot and, say, humid. I used to live in Florida, and not only was it hot, but it was also very humid in the summer. So it really made it very difficult to, say, go running during the daytime. But surprisingly, despite the fact that it's quite stressful to exercise in a hot environment and there are high levels of cortisol, which we know suppresses in the short term the immune system, there's in fact no evidence that there's any impairment of the immune function. So that's just very interesting. I don't really know the explanation for that. I mean, perhaps, the high temperature actually in itself is somewhat, protective. Just think about having a fever or something like that. A fever is your body's natural response to, say, a bacterial or viral infection. So high temperature itself may make the internal environment of the body less conducive for, say, viral replication. But that's just speculation. Exercise in the cold. So it's well known. Everyone, we call an upper respiratory infection often a cold, right? That's just standard. And your mother's told you not to go out, without a scarf on and things like that, or a hat. But there's actually no evidence that first of all, cold temperature or exercise in cold temperature has any sort of negative impact on the immune system. So when we're talking about this, we're not talking about extreme cold. Like if you actually have hypothermia and you're very seriously cold, then that would, seriously impair the immune system. But as long as we're talking about just sort of more moderate levels of cold, there's really no negative effect at all on the immune system. People have also studied exercise at high altitude, and by high altitude, we're talking quite high. About 6,000 feet would be really high. Say the mountains of Colorado. So this can be quite stressful, again, for reasons we haven't really talked about, but it stresses the respiratory system, for example, because there are lower levels of oxygen in the air. So if you exercise at high altitude, you'll have increased levels of cortisol, which we know does typically suppress the immune system. However, at least when studied in the lab, this doesn't really have any functional effect on the immune function. In other words, people aren't any more likely to get sick. Well, things are a little bit different in the field. When people have actually gone to high altitude, they do find that there's an increased risk of upper respiratory tract infection. And the reason for this effect is probably multifold. When you're at high altitude, first of all, as I mentioned, you have a lower oxygen level in the air, and so people have to breathe faster and deeper. This ends up changing the pH balance of the blood. The blood becomes more alkaline. People at 6,000 feet can experience high altitude sickness, so mountain sickness, acute mountain sickness, AMS. And there are other effects. So I think it may be cold also at high altitude. So when you combine these things in the field, then yes, there does seem to be an increased risk of upper respiratory tract infection. Okay, I want to address a little bit more of the idea of this idea that cold weather increases the risk of infection. So as I said, the scientific evidence is that actually being in a cold environment, either acutely or for a prolonged period of time, or exercising in cold weather doesn't by itself increase the risk of infection. However, it's very clear that the cold and flu season would be in fall and winter. So clearly something is going on. There definitely are more respiratory infections during those months. So how does that occur? Well, first of all, as I said, cold exposure in and of itself does not increase the risk of infection. But there are a number of things that do. People spend more times indoors when it's cold, so you just simply have more community spread between people. You also have the fact that a lot of common cold-causing viruses survive better in low humidity environments. In other words, if you touch your face and you're sick, and then you touch a doorknob or a railing or something like that, then that virus will survive longer in a low humidity environment than it would in a higher humidity environment. And typically indoors, we're going to have, well, it's a little hard to get into the physics of it, but basically when you have low temperature in the environment, such as the air outside, that air can't hold a lot of humidity. And then you take that air and you bring it indoors and you heat it up. So now it's at a warm, comfortable temperature, and yet the humidity is very low because you're bringing in outdoor air that had a very low humidity. And it's quite easy to get around that. You can just simply use a humidifier, and that will make the air more humid and more comfortable. So then finally, cold weather can also dry out the inside lining of your nose. So remember we talked about the fact that you have this sort of external defense, which is part of the innate immune system. And part of that, when you have mucous membranes, such as in the respiratory tract, you'll have you have mucus producing cells, but you also have ciliated cells. And so what will happen if the air is dry enough is those cilia will dry out and die. Now, it's not permanent. As soon as the humidity comes back, those can regrow. But if you're missing those cilia, then it makes your upper respiratory tract much more susceptible to penetration by, say, virus or by bacteria. Okay, so let's talk a little bit about practical advice. So should you exercise when you have a cold? So it's generally thought to be okay to exercise if the cold symptoms are above the neck, right? In the upper passageway. So if you have a runny nose, nasal congestion, mild sore throat, those are probably fine, but it's advisable to reduce the intensity and duration of the workout nonetheless. On the other hand, you should not exercise if the symptoms are below the neck. If you have chest congestion, difficulty breathing, cough, stomach pain, all those would indicate that you really shouldn't exercise. Furthermore, you shouldn't exercise if you have a fever, if you feel fatigue, sort of general fatigue you'd have with the flu, or also if you have widespread muscle aches, again, that would indicate that you have some sort of flu, which is often a viral infection. Okay, so here's some of the take-home messages from this last bit that we just talked about. So although exercise and heat does cause an increase in circulating levels of stress hormones, such as cortisol, exercising in hot environments does not pose a greater threat to immune function compared to exercise in a cooler environment. So it's very interesting. We don't quite know exactly why that is. Research does not support the popular belief that short or long-term cold exposure by itself, with or without exercise, suppresses the immune function and increases the risk of infection. Of course, there are other things that do lead to the increased infection, which we talked about. And then prolonged high-altitude exposure, living in the mountains, combined with exercise, can increase the risk of upper respiratory tract infection. And so one last point I should make on that is that when you move to, say you want to go on a ski trip in Colorado or something, or you're just going to a high altitude city, you probably should plan in a few days of just rest. I know people often can't do that because of their schedules and so forth, but it would be advisable because your body will adjust to high altitude, but it takes, it can take up to a week or even longer to really fully adjust. But I would give yourself even just a few days before you started doing some really strenuous exercise at high altitude. And finally, it's typically okay to exercise during cold if your symptoms are limited to a runny nose, nasal congestion, and mild sore throat. It's not wise to exercise if your symptoms are below the neck, so chest congestion, cough, or stomach pain. Also, don't exercise if you have a fever, or general fatigue, or widespread muscle ache.